It takes billions of years for a galaxy like our Milky Way, with its hundreds of billions of stars, to form. But the James Webb Telescope spotted 6 galaxies that popped into existence just 500 million years after the Big Bang. Get this, they're up to 10 times bigger than the Milky Way. That shouldn't be possible. What if the edge of the universe isn't the end, but the start of something way more mysterious? The James Webb Space Telescope just peered farther than ever before, catching light from almost the beginning of time and showing us galaxies that are older than our models predicted. Michio Kaku calls it a peek into creation itself. What Webb found isn't just old, it's weird, shaking up our cosmic timeline and hinting at forces we don't get yet. Could this point to early black holes or even other universes? One thing's for sure, the edge of the universe just got a lot closer. We'll kick things off by pointing jwst at the edge of the observable universe, about 46.5 billion light-years away. That edge isn't a real thing, it's set by how far light has had time to travel to us since the Big Bang. Telescopes can't see infinite space, only as far as light has reached us. jwst's killer infrared vision lets us see that light that's traveled across an expanding universe for over 13 billion years. Right away, the telescope blew past old records. Distant specks of light, just blurs to Hubble, now show up as almost 44 separate galaxies, some with redshifts above z equals 13. That means their light started after the universe was 300 million years old. As Michio Kaku said, we're seeing the first galaxies form. This isn't just a saying, it's what jwst is actually doing. It's not just a faint glow, but fossil light, actual imprints of the first stars switching on in those galaxies. These stellar nurseries give us clues about the universe's earliest days, and we can finally check them out. jwst doesn't just find them, it splits up each galaxy, giving us snapshots of early cosmic neighborhoods. And get this, these images aren't just cool to look at. This is history written in light. With every bit of light jwst grabs, we see more clearly the seeds that grew into galaxies like ours. According to Kaku, we're seeing the start of cosmic structures, a discovery that changes everything. Next up, we'll get into how jwst's record-breaking redshift discoveries are forcing us to rethink cosmic timelines and star formation. It turns out our universe got going earlier and faster than we thought. jwst has reset the bar by locating galaxies having redshifts greater than z equals 13, meaning they lived after the universe was only 300 million years old. Previously, scientists assumed that there were only a few of the most ancient galaxies. Webb delivered near 44 inactive candidates from the cosmic dawn. These results make our previous timelines appear slow and careful. Imagine finding churches developed in a settlement that many believe to be huts. Kaku marvels these galaxies are urban centers, not glimmers in the cosmos. Not only is jwst displaying more galaxies, but the details and brightness are more than expected. The standard models of cosmic inflation assume less growth. Webb gives a universe that sprinted and didn't march. Our models may require some rewriting. If the galaxies develop early, the main assumptions about dark matter and gas cooling need to be reviewed. With the record shifted, it's clear that early galaxies are not only numerous. We will discuss these structures in the following section. The images of jwst show the structures of galaxies when the universe was only 200 to 400 million years old. The deep field pictures display galaxies with structures appearing when the universe was at the very beginning. We're watching star-forming areas glowing in proto-galaxies. Kaku says we are watching the first steps towards galaxies like our own. The observation shows how the systems interact and grow with dark matter. It tells us how the first stars are observed. We can measure the mass and star birth because of the revolutionary structural observation. Kaku explains what the cosmic scaffolding from which everything grew is. We turn to a suggestion, which is that the early galaxies are fast. The James Webb Space Telescope didn't open the universe's windows, but the entire door. We found both thrilling and troubling. The modern cosmology backbone describes how dark energy and dark matter shape space. It is showing cracks. According to standard theory, jwst's observations show the theory. Kaku says the galaxies matured at warp speed. If so, galaxies quickly developed, so ideas about the early dark matter halos need to be rethought. Those physicists may require extra pieces. The questions turn to possibilities such as black holes that form from stars. One of jwst's unexpected signs comes from glows that don't agree. The black holes could be born from cosmic inflation. If real, this black hole could be the seed for galaxies increasing. Kaku mentions that the concept changes what lights the cosmic dawn. Also, the black holes have been proven to hold mysteries of lighting material that doesn't reflect light. Some believe that ancient holes are dark matter. Webb isn't given proof that spectral distortions are giants that hide in the ancient space. Kaku warns that we had shadow stars. What is an understanding of the stars? We must have a turning point from the cosmic time from era ionization. At a time, the universe was filled with hydrogen. After the Big Bang, there came a long period in which there were no stars. Then it changed. The stars gave light. And the universe was on. The universe is giving light. We are seeing in real time the Lyman light of galaxies. Mapping bubbles is a way that scientists use to track the transparent light. This process tells us how the stars formed. The universe is getting on their source of light. It even gives estimate calculations such as stars. Kaku says the light has shadows that expand. It can hold secrets. In the chapter, the Webb is turning to gaze at alien possible worlds. The edge is where the time exists that we see potential lives. The James Webb Space wasn't designed for life in the universe but atmospheres from other planets. Michio Kaku mentions that we may be on the verge that the Earth has life. Webb has ability to break up the molecule that shows if there is light given off in the chemical makeup like photosynthesis. We may get chemistry from WASP-96b. While it is too warm to determine the power, future planets will become smaller. Kaku stresses that being away from our planet helps us know life closer. The history is shown to be in the biology. We are here again from possibilities instead of theories that seem incomplete. The human is a deep person in this trip. Life exists outside or in the skies here. The universe connects with science. Wonder has been expanded in which we are here for this creation. Bold questions have been asked. Because out there, light is traveling, please like and subscribe. We've seen the structure. Now for something huge. These early galaxies are too big, too fast for our old models. That's up next, why standard cosmology is being questioned. The James Webb Space Telescope didn't just open a view of the early universe. It threw the door wide open. What we found is amazing and troubling. Many of the bright, old galaxies Webb showed seem too big, organized, and bright to fit our trusted models, like LCDM theory. This model is the base of cosmology theory and shows how dark energy and dark matter formed the universe. But now it's got problems. The galaxies seen at extreme red shifts, some less than 300 million years after the Big Bang, seem to have formed stars fast and well. That's not thought to happen. Standard theory says stuff needed time to cool, come together, and light up. But JWST's findings say something else. Kaku makes it simple. The universe skipped being a teenager. These galaxies grew up fast, hinting at science we don't get yet. If galaxies formed faster, then we need to rethink our ideas about early dark matter, what cosmic feedback does, and how warm early gas clouds were. Some scientists are changing inflation theory, while others are thinking about other ways dark matter acts. LCDM isn't broken, but it might be missing some pieces. This is what physicists want. As Kaku says, our models might need change, not because they're wrong, but because the universe is more imaginative than we are. And imagination with what we see starts finds. With cosmology questioned, researchers are thinking about wild things, like black holes that formed not from stars, but the Big Bang. The next part looks at these old things and hunting for beginning black holes. Strange infrared light gives one of jwst's biggest hints. This light doesn't match young stars or galaxies. It might be from old, dark things, black holes formed right after the Big Bang. These might be smaller, mini, and born from tiny changes right after cosmic inflation. If true, these black holes could be the seeds galaxies grew from. That changes it all. Normally, we think galaxies form stars, and black holes grow in their centers. But what if the black hole came first? Kaku says it changes how we see the start of space. These tiny monsters might have pulled in matter, started early star bursts, and formed the universe. Plus, beginning black holes could explain dark matter, stuff that makes up much of the universe but doesn't send out or reflect light. Some think that these old black holes are dark matter, or some of it. If true, that would solve a big physics problem with one simple answer. Webb hasn't proven they exist yet, but the hints are adding up. The differences in light, how gravity changes it, and mismatched brightness show hidden giants in space. As Kaku warns, maybe we're seeing shadows for stars. What took away the darkness? To get how stars began to light up, we need to look at when the universe changed. That's next, seeing cosmic change. The universe was dark once, filled with hydrogen fog. After the Big Bang and light, there was a long dark time where no stars were around. Then, things changed fast. Stars lit up, galaxies made up, and the universe shined. This is called cosmic reionization, and jwst is seeing it happen. Webb sees things called the Lyman Alpha Forest, shadows in the light of faraway galaxies. These shadows show areas of ionized hydrogen, where starlight has blasted away the fog. By seeing where these areas are, scientists can follow how reionization crossed the universe, changing it to what we see now. It tells us how fast the first stars formed, how galaxies grew, and how early light changed space. We're watching the universe learn to shine, says Kaku, like seeing the first campfires on a dark land. These seeings also help us guess how long the first objects were around, their heat, and how they changed nearby space. Some say that super big stars, hundreds of times bigger than the sun, burned fast and hot, helping the reionization timeline. The light we see now holds stories of light, dark, and growth, the universe's story written in starlight, as Kaku reflects. It might hold secrets of life. Next, we'll see how James Webb is looking at other worlds and what it might find. Where time seems slow, we are also seeing potential places for alien life. The James Webb Space Telescope wasn't made to find aliens, but to study the air around exoplanets, places where life might be. Michio Kaku says this time in science is big. He says, we might be answering an old question, are we alone? Webb can see infrared spectra, the light going through a planet's air, to look for things like water vapor, methane, oxygen, ozone, and complex molecules like phosphine that could mean life. The telescope has looked at planets like WASP 96b, finding traces of water. While WASP 96b is too hot for life, this shows what the telescope can do. Future looks will be on smaller, rocky exoplanets and places where liquid water could be and air could help processes like chemistry. Kaku talks about why this work is big. Getting how the universe made helps us get life's place. If life is out there, it probably started around the same time life began here. That would change our story, not just Earth's, but one part of the universe's biology. We asked what's at the edge of the universe. Now, after learning through the James Webb Space Telescope, we're left with bigger questions. Webb didn't just take clearer photos. It peeled back time. It showed us the early universe was more active, structured, and weird than we thought. Galaxies forming stars fast, likely showing black holes born at the start. Webb's findings shake cosmology. The models we've used now seem missing things. We're entering new space, as Michio Kaku says. The physics we know might be one small part of a bigger story. Beyond physics and theory, there's something human in this. We've looked to the sky for meaning, and with tools like Webb, we're seeing more. Maybe there's life or other universes. The edge isn't an end but a start, one that takes science to thoughts and curiosity defines. Science is what makes us do well and wonder, and with each image from Webb, we're getting more. We're getting what it means to be human in a universe so big. Maybe that's what we're really finding. That even in a universe with galaxies and dark energy, we can ask big questions and dream big answers. As we look beyond the edge, remember the universe isn't done telling its story, and neither are we. Thanks for joining us. If you like the universe content, then don't forget to hit the like, share, and subscribe button, just somewhere out there. Light still continues traveling toward us with the next great revelation that might be one image away.